Most of us think of the internet as like this weightless ether, right? It's pulling data out of thin air. But if you were to cut into the ceiling of a massive enterprise data center right now, well, you wouldn't find magic.
No, definitely not. You'd find thousands of microscopic, honestly, terrifyingly fragile glass threads.
Yeah, threads literally carrying lasers at the speed of light.
Exactly. And wrapping those incredibly delicate glass threads in, the exact right kind of armor is a massive high-stakes engineering challenge.
Which most people never even think about. So welcome to today's deep dive, our favorite curious learner. Our mission today is to decode the actual physical backbone of our wireless world.
Right, and we're zooming in on a single source today, which is an e-commerce product page from HDTVSupply.
Yep, for a product called the Get Ready for This, the DVIGear DVI-2310-FOD 8XLC 50125U MMF Optical Plenum cable.
It is quite the alphabet soup.
Okay, let's unpack this, because on the surface, it's essentially just a 10-meter black cord. But let's look at that string of letters and numbers, the 8XLC 50125U MMF part. Like, what does that actually mean in practice?
Well, let's start at the end there with MMF. That stands for multimode fiber. So instead of, copper wire conducting electricity, this cable transmits data using really rapid pulses of LED or laser light.
Oh, wow.
Yeah. And the 8XLC simply means there are 8 distinct factory-terminated connectors at the ends.
Right, so it's basically like an 8-lane digital superhighway.
Exactly, yeah, for multi-channel use. But what's fascinating here is the physical geometry hidden in that 50/125U specification.
Right, the source explicitly lists that measurement. And I know the U usually stands for microns, right?
It does, yeah. The 50 is the diameter of the central glass core, so 50 microns across.
Wait, really? That's like roughly half the thickness of a human hair?
Yep, it's incredibly thin. And then the 125 is the cladding, which is an outer layer of glass that wraps around that core.
So we are shooting lasers down a tube half the width of a hair. I mean, how does that light not just bleed out the sides the second the cable bends around a corner?
Well, that is exactly where the cladding comes into play. It's manufactured to have a lower refractive index than the core itself.
Ah, okay.
So this creates a mirrored boundary. When the light pulses hit that boundary, they just bounce right back into the center.
Oh, I see.
And that's what multi-mode actually means.
Mm-hmm.
Multiple rays or modes of light are bouncing down that 50-micron core simultaneously, just at different angles.
So it's like skipping dozens of stones down a perfectly mirrored microscopic water pipe.
That's a great way to put it. You can send massive amounts of data concurrently because the light just keeps reflecting inward.
Which maintains the signal integrity over distance. That's wild.
It's incredibly efficient, but, it creates a distinct vulnerability. Glass that thin is obviously susceptible to physical shear and temperature.
Right, which raises a structural problem because you have this hyper-fragile glass core carrying all this critical data.
Yeah.
You can't just leave it exposed, especially when routing it through, like, the harsh environment of a commercial building's drop ceiling.
Right. The environment dictates the armor. And the specs here highlight a Plenum-rated black jacket.
Okay, so why does the jacket material matter so much?
Well, a plenum space is the structural area used for air circulation in a commercial building. It's that massive open void where the HVAC system pushes air.
Oh, so if a fire breaks out in a server room, those air spaces are going to rapidly pull that fire and smoke everywhere else in the building.
Exactly. And standard cable jackets are usually made of relatively cheap PVC.
Which is bad if it catches fire, I'm guessing.
Very bad. If PVC burns, it releases highly toxic hydrogen chloride gas.
Yikes.
Yeah. So a Plenum-rated jacket carrying what's called a CMP rating is manufactured using special low-smoke materials like fluorinated polymers.
Got it.
They're engineered to resist burning and, more importantly, emit almost no toxic gas if a thermal event actually happens.
Okay, but let me push back here for a second. The price tag is $249 for 10 meters.
Right.
That is just under 33 feet. For a piece of networking gear, isn't that price like total overkill for anyone just trying to set up a standard network?
Well, I have to disagree. If we connect this to the bigger picture, you really have to look at the deployment environment.
Okay, how so?
You aren't buying this to wire up a consumer router in your living room. These go into medical imaging facilities, broadcast matrices, and massive enterprise server farms.
Yeah, that makes sense.
Right. If a standard cable melts and shorts out during a fire, or even just fails under normal mechanical stress, the network downtime there can cost tens of thousands of dollars a minute.
Wow. Yeah, that tracks with the broader context of the source, actually. I mean, HDTVSupply has been around for 25 years and boasts a 4.7 out of 5-star rating.
They do.
And there's a specific review on this page from a retail operator who deploys these exact DVI gear systems across multiple commercial locations.
Yeah, and notice they aren't citing the price in that review. They are citing the absolute reliability for their staff.
Right, because when downtime isn't an option, it's an investment.
Exactly. When you manage an enterprise network, a $249 cable backed by a 3-year DVI gear warranty is basically a rounding error compared to the catastrophic cost of an outage.
Right.
You are paying for the engineering guarantee that those 8 strands of 50-micron glass will absolutely not fail.
So what does this all mean for you listening right now?
Well, every time you enjoy a flawless 4K stream or, pull complex data from the cloud in milliseconds, it relies on this.
Yeah, it relies entirely on heavily regulated threads of glass hidden right above your head.
The wireless world is firmly anchored in physical infrastructure.
It really is. Which leaves me with this thought for you to chew on today. As our appetite for bandwidth grows exponentially, the physical hardware required to support it in our ceilings and walls must also expand.
Has to, yeah.
So what happens when our commercial buildings simply run out of physical space to house the invisible backbone of our wireless world?